Day 8. Predict house prices with linear regression. Now let's use the California housing dataset to predict house prices with linear regression. This dataset contains information about different districts in California and includes features such as population, median income, house age, and more. Let's see how we can get that rolling. So first, let's go ahead and create a new file for today, which is our day 8.py. Now here, first thing that we need to do is, let's say, import necessary libraries. And those libraries being pandas as first PD. Now this will be used to handle data manipulation. Next, we need sklearn dot datasets import fetch underscore California underscore housing. There's a particular library in here. Fetch California housing imports the California housing datasets. It's part of the sklearn datasets. Next one, I need to get sklearn dot model selection for selecting our model. Which before even selecting the model, we need that train test split. Now this splits the data set into training and testing sets, so that's what we're using this for. And now we'll need to get our model from linear model. I'll say import linear regression. So I have that, and finally I will say sklearn dot metrics import mean squared error and r2 underscore score. So in the previous thing, we implemented the linear regression algorithm to predict house prices, and next we have the mean squared error R2 score. These are the metrics used to evaluate the performance of the model. And finally, for some numerical operations, I'll say numpy as np. So I have everything that I need. Now the next step is to load the California housing dataset. I can do that by creating a variable called as housing equal to fetch California housing as a data frame. So I can say as frame equal to true. So this loads the California housing datasets and return it as a pandas data frame. Now this dataset contains features like median income, house age, average number of rooms, and others, along with the target variable, which is the median house value, which is actually in hundreds and thousands of dollars, hundred thousands of dollars. So if it's one, which means it's 100,000. If it's 1.5, it means 1.5 million. So let's go ahead and create a data frame from the dataset. Now to do that, I can just say df equal to housing dot frame. So that will convert the data set into a data frame for easy manipulation. Now next, I would want to display the first few rows of the data set just to show you how it looks like. So now what we can do is we can print the first 5 rows of California housing data frame to give us an overview. So I can just say print California housing data, and I can just say print, you know, this command df dot head, which will give me the first 5 rows. If you want to check it out, I can just go ahead and clear ls, and I can say python day 8 dot py, and it will give me. So if you see that medium house value is at the end, but it has bunch of different options: latitude, longitude, average rooms. It has bunch of other options. That's why it's showing dot dot dot, but it has some columns in here. So I have my 5 rows displayed. Now next step that I want to do is I want to get the features and target, which is the dependent variable. So we will get x, we'll call it x, or let's put a features and target. Now as I mentioned, target is dependent variable and features is independent variables. So this I can get by saying x equal to which x is the features which I mentioned as the independent variable that will be used to predict the median house value. So I need all the columns except the last column, which is the median house value in the features. So to do that, I can just say df dot drop, and the one that I want to drop, I can just copy it from here. Median house value axis equal to 1. So this will drop the column median house value. And now for my target, which means what do I want to, the target variable is the median house value, which represents the median house value in hundreds of thousands of dollars. So I'm going to take that and put it here. That's what we want in my target. Now, next thing that I want to do is I want to split the data set into training and testing sets. So I'll say split the data set into training and testing. So now to do that, I have already used that train test split. I've imported that. I can take that, and in here I can pass x comma y, my features and my target. I can just say text size equal to 0.2, which is 20% of them will be used for testing, and then I'll use random state equal to 42, which is my key used to make sure that the split is always the same no matter how many times how I split it. X underscore, it will give me x underscore train, x underscore test, y underscore train, and y underscore test. So that's what I get here with my splits. So now I have all the data that I need. So now first thing I'll do is I want to train the linear regression model. For that I need to get the model. So I'll say linear regression. Nope, I said logistic. Nope, linear regression. And then I'll say model dot fit, and I will fit x underscore train and y underscore train. So what this does is it initializes the linear regression model, and then the fit function trains the model using the training data x underscore train and y underscore train. So once I have that, let me just move it a little bit up. And once I have this data, next thing that I want to do is I want to make predictions. So I'm going to say make predictions on the test set. So I can say y underscore pred equal to model dot predict x underscore test. So this uses the trained model to predict the median house value for the test set. So next thing that I want to do in this particular case would be then to evaluate the model based on my training and testing. I can get something called as the mean squared error and R2 score. Now mean squared error calculates the function means underscore square underscore error calculates the mean square error, which measures the average squared difference between the actual and the predicted house values. Whereas R2 score calculates the R2 score, which indicates how well the model fits the data. And R2 score closer to 1 means better performance. So to do that, let me say I want to evaluate the model using mean square error and R2 score. Now to do that, I'll say MSE equal to mean squared error y underscore test and y underscore pred. So this will give me a good idea. R2 equal to R2 score, and again the same things, y underscore test and y underscore pred. Now if I want to print it out, I can just say print f of mean squared error equal to, you can just say MSE. And now for my R2 underscore, I can just say R2. So that will give me the output over there. Now, if I want to display the coefficients of the model, let me just move it up. If I want to display the coefficients of the model, I can say print. Let's say I want to display the model coefficients. The way to do this is I can say print f and intercept is model dot intercept underscore. So what this does is this displays the intercept of linear regression model. So that's what this will give us. Now if you want to display the coefficients for each feature, you can do that by saying f and let's say coefficients equal to model dot coef underscore. That will give me coefficients for each feature. Next, we can create a data frame for the coefficients with their corresponding feature names. I can do that by saying coef data frame equal to pd dot data frame, and inside that the configuration, the different arguments that I need is one is model dot coef underscore, which is all the coefficients for each feature. Next, I say x dot columns, and I'll say columns equal to, so this will create a column called as coefficient. Okay, so that makes that creates a data frame for to show the coefficients alongside their corresponding feature names, making it easier to interpret the results. So now I can say next, let's print this out saying coefficients for each feature is, I can just say print in a separate line coefficient data frame. Now let's test the model finally. So I can just say test the model with new data. I'll just create a new data object. Let's move it up. Now if I want to create a new data object, I can just say new underscore data, create a variable, and I can say pd dot data frame, and inside this I want to give, based on some of the things that it have, median income is, I'll say 5, and then house age, can give that house age equal to, let's say 30 years old. 30 years old. I want to give average number of rooms, which is AVE rooms is equal to, let's say average number of rooms in this house is 6, and average average bedrooms, I think BEDRMS, if I'm not wrong. If I'm wrong, I'll get an error, but I can leave it there. I can say average bedrooms is 1. Population that neighborhood is around, let's say 500. Average occupancy, average OCCUP is 3. Now I need to give latitude and longitude, so that will be latitude is, I think California is roughly 34.05, that's what we'll give, and for longitude I'll give, I think it's roughly 118 minus 118.25. So that kind of creates my new data object. Now for this I want to get the predicted price, predicted underscore price. I'll create a new variable and I'll say model dot predict, pass the new data, and then let's print. I'll say predicted house price, and inside this I'll use the dollar sign and I'll say predicted price at the object 0 comma 0.2 f, so it has the right Values looks fine. I think I also have to say F here. So it's, and then I'll move it a little bit down so it's clearly visible. So let's go ahead and run this. So I got the head first, then I got the mean square error, which is 0.55. R2 score is 0.57, so it's not that good. Model coefficient intercept is this much. Coefficients, these are the different coefficients for each and every feature that we have. And it shows these coefficients here in a nice column way. And the predicted house price for whatever we mentioned, I mean, it has average rooms is 6, house age is 30 years old house, medium income is around 5. So given that fact, the house is around $254,000 because it's in hundreds and thousands of dollars. So that's the price, predicted price of this particular house that we have provided here. So this is how you can predict house prices using linear regression that we've used here, and it kind of gives you a better answer. But there are better models out there to do this. But at least you kind of understood how we got to predict house prices using linear regression. And if you had any issues or any problems while implementing this, let me know and I'll get back to you.